today's lesson we're again dealing with equations involving algebraic fractions. These are the ones that we solved in the last lesson, so it is important that you watch that video so you're up to speed with where we're at. We're going to move on with our next three examples, and they are getting progressively harder. So again, dealing with equations, we're looking to solve and find A in this example. We have an algebraic fraction on the left hand side of this equation, and what we're basically looking to do is get rid of the algebraic fraction. So what we need to do is get rid of the 3 on the bottom. So like anything in algebra, when we're solving, I remember I explained this yesterday, and it's also in our previous lessons when we're dealing with solving equations. If I want to get rid of this 3 is dividing on the left hand side. To get rid of a divide by 3, we multiply by 3. But with an equation, what we do to the left hand side, we have to do to the right to keep it balanced. So if I'm multiplying by 3 on the left, I have to multiply by 3 on the right. So that gets rid of that 3 on the bottom. So I'm left with 2a plus 1 is equal to, and everything over here is multiplied by 3. So you can't do 3 open bracket a minus 2 close bracket and then multiply it out, or you can just multiply both of these terms straight away by 3. So it becomes 3a minus 6. Now again, we're dealing with an equation where we have unknowns on both sides. So we're looking to get rid of one of the a's on either the left or the right hand side, so we can get rid of either the 2a or the 3a. It doesn't really matter. I'm going to get rid of the 3a. So to get rid of 3a, the 3a is positive. This minus, remember, is in reference to this 6, so this is a positive 3a. So to get rid of a positive 3a, I subtract 3a. If I subtract 3a from the right, I have to subtract 3a from the left. And again, I'm taking it away from the a's. So 2a take away 3a is minus 1a, or just minus a. Still got our plus 1 is equal to minus 6. Now, to get rid of this plus 1, I minus 1, because remember, I want to get a on its own. So if I minus 1 from the left, I have to minus 1 from the right. So I'm left with minus a is equal to minus 6 take away 1, which is minus 7. So if minus a is minus 7, positive a is positive 7. Okay, so I'm just changing the signs there. And again, if I want to check my answer, I can substitute a equals 7 back into the original equation. So 2 times 7 is 14, plus 1 is 15. 15 divided by 3 is 5 on the left. So again, if a was 7 on the right, a would have 7 take away 2, which is also 5, so that makes perfect sense. You can do a wee bit of work on it to prove that, but again, it's just a case of substituting back in to check your answer. So our next example, again, we have an algebraic fraction on the left. We want to get rid of that in terms of being a fraction, so I need to get rid of this b plus 3 on the bottom. So because it's dividing, I multiply the whole left hand side by b plus 3, but remember, I have to do that to the right as well. Okay, so what this does is it gets rid of the b plus 3 on the bottom. So what I'm left with on the left is 2b minus 1 on the left is equal to 9 times, and I am going to use the bracket here just to show you what this means, 9 times b plus 3, because I have to multiply b plus 3 times everything, so that's why I'm going to multiply 9 into this. Okay, so I'm left with 2b minus 1 is equal to, so I'm going to expand the bracket now. 9 times b is 9b, 9 times 3 is 27. Okay, so now I've got b's on both sides here. I'm going to get rid of the 9b, so I subtract 9b from the right. I generally like to keep my unknown value on the left. So 2b take away 9b is minus 7b. Still got my take away 1. It's equal to, that's gone. It's equal to 27. Alright. Now I need to get rid of this minus 1. So I plus 1 to the left, and I have to plus 1 to the right. So I'm left with minus 7b is equal to 28. And now what I'm going to be doing is I'm going to get rid of this minus 7. But remember, this minus 7 isn't subtracting with the b, it's multiplying. So I'm going to divide by minus 7 on both the left and right. So just be careful of that. Okay, so divide by minus 7. Alright, so that gets rid of the minus 7 on the left. So I'm left with b. 28 divided by 7 is 4, so 28 divided by minus 7 is minus 4, because that is a positive divided by a negative. And I can substitute that back in if I want to check my answer. So if b was minus 4, 2 times minus 4 is minus 8. Minus 8, take away 1 is minus 7. And then I've got minus 4 plus 3 on the bottom, which is minus 1. Minus 3 plus minus 4 plus 3 on the bottom, which is minus 1. So I'm dividing by 1, and I'm dividing two negatives. So therefore that makes sense, because I would end up with minus 8, take away 1 on the top, which is minus 9. Minus 9 divided by minus 1 is positive 9. Okay, so again, just substitute and then check my answer. Last question we're going to do today. Alright, so this takes us on to where we have two algebraic fractions on the left hand side of the equals. So what we have to do is, and this is where our previous lessons come in handy on dealing with expressions involving algebraic fractions, we have to change these two algebraic fractions into a single simplified algebraic fraction. So what I'm going to do is I'm going to find, because these are adding, I'm going to find a common denominator by multiplying the two denominators. So 2 times 4 is 8. And then I cross multiply to change the numerators. 4 times everything up here gives me 4c plus 12. Plus 2 times everything up here, 2c plus 2. And if you're a wee bit rusty on that, just watch the video on adding algebraic fractions to form a single simplified algebraic fraction. And that is all equal to 10. Now simplify on the top line, so what I end up with is 4c plus 2c is 6c, 12 plus 2 is 14, all over 8 is equal to 10. Now this is like our previous question that we had here, where we have an algebraic fraction on the left. It's a single algebraic fraction, so I'm going to get rid of that 8. So to get rid of that 8, I multiply by 8, and I have to do the same to the right hand side. So I'm left with 6c plus 14 is equal to 10 times 8, which is 80. And now I'm going to get just a two-step equation. Now I'm going to get rid of the 14 by subtracting 14 on both the left and the right. So I'm left with 6c is equal to 66, and then I just simply divide by 6 to get rid of the 6. So I'm left with c is equal to 66 divided by 6, which is 11. Okay, again, substitute back in to check my answer, but I know that's fine. I'm going to post some questions for you to have a wee go at, and anything you're unsure about, just ask.